afternoon, students. Today we are going to talk about manufacture of nitric acid. And the manufacture of nitric acid, first you should know that we are going to use the Ostwald's process. So the raw materials needed are, we have ammonia. Let's talk about the raw materials. We have ammonia, which is from Haber process. Then we have the catalyst, and then we have air and water. Air, then water. These are the raw materials needed in the preparation of nitric acid by Ostwald's process. We have ammonia, which is obtained from the Haber process. Then we have the catalyst, then air and water. So the optimum conditions, we have also the optimum condition. These are the things that you should take note of, because you can be asked in an exam to state the raw materials required during the preparation of nitric acid, then the optimum condition, most likely in paper 2. So optimum condition, have the optimum condition. You have excess air, have platinum catalyst, excess air, platinum catalyst, and a temperature of about, should be about 850 to 900 degrees Celsius. The optimum condition, first we have the excess air, platinum catalyst, temperature of about 850 to 900 degrees Celsius. Here you can use platinum catalyst or rhodium catalyst. It is abbreviated as RH, but it's better to write the full name, rhodium catalyst. For those who don't know rhodium is just an element in the periodic table, but this is not taught in the periodic table at high school level. There we go. So let's talk about the process that take place during the manufacture of this nitric acid. So at the first stage, ammonia reacts with oxygen and it is oxidized to nitrogen 4 oxide. Ammonia reacts with oxygen. So here we have oxygen and ammonia. This is the first step in the compressor, whereby ammonia is going to react with oxygen. So obviously you are going to have the equation. When you are asked to write the equation, you write the equation between ammonia plus oxygen. We are going to get ammonia plus oxygen, nitrogen 2 oxide plus water. This liquid, gaseous, ammonia, gas. So this equation is not balanced. The equation must be balanced. Here we have 4, 5, 4, 6, 4, 5, 4, 6. So if you look well at this equation, this is just the equation for the catalytic oxidation of ammonia, which the catalytic oxidation of ammonia, this is how it occurs. And in this equation you must have the catalyst. So the catalyst that you are going to use, we have said here the raw materials, we need to have the catalyst, and the catalyst is going to be platinum or rhodium catalyst. This is the catalyst that you are going to use. So if you are asked to write the equation that is going to occur at the first stage, maybe you can get this diagram in an exam. They ask you to write the equation that is going to occur at stage A. Let's assume that this is stage A. So this is the equation that you are going to write: ammonia plus oxygen to form nitrogen oxide plus water. That is at the first stage. So at this first stage, this way we are going to get the temperature that we have said, a temperature of about 850 to 900 degrees Celsius. This is the temperature that is going to be used at the compressor or the first stage. Then the nitrogen oxide is mixed with air to form nitrogen oxide. The nitrogen oxide is mixed with air to form nitrogen oxide. So this nitrogen oxide, it is formed at this compressor. The nitrogen oxide formed. Here you have nitrogen oxide. Now nitrogen oxide will move from this stage A to stage B. So nitrogen oxide in stage B, nitrogen oxide, we have some oxygen. Nitrogen oxide is going to react with oxygen to form nitrogen oxide. Nitrogen oxide is going to react with air to form nitrogen oxide. So the equation that you are going to write, the equation between nitrogen oxide. Here is the equation: nitrogen oxide plus oxygen to form nitrogen oxide. The equation must be balanced. That is the equation that is going to occur at stage B. So this is another question that you can also be asked. Write the equation that is going to occur at stage B. So that is the equation that you are going to write. So in this stage B is where you are going to have the conditions and the condition and the catalyst that you are going to, sorry, not the catalyst, here the condition, we have said the temperature must be between 850 and 900 degrees Celsius. Now let's just say 860 degrees Celsius. This is the condition at stage B, where the nitrogen oxide formed in the compressor is going to react with the oxygen to form nitrogen oxide. Now nitrogen oxide is moving from from stage B to stage 3. Stage 3 is the cooling chamber. Stage 3, the cooling chamber. Nitrogen oxide is now moving to the cooling chamber. So nitrogen oxide is passed through water to form nitric acid and nitrous acid. This nitrogen oxide is passed through water to form nitric acid and nitrous acid. So this water, nitrogen oxide, water is added to nitrogen oxide to form nitric acid and nitrous acid. That is another equation that you need to write. So the equation is going to be nitrogen oxide plus water. Nitrogen oxide plus H2O to form nitric acid and nitrous acid. Nitric acid and nitrous acid. This is the formula of nitrous acid. The difference between nitric acid and nitrous acid: nitric acid has 3 oxygen, while nitrous acid has 2 oxygen. Nitrous acid has 2 oxygen. So here is 2. That is the equation that is going to occur at the cooling chamber. So that's it. Then excess air. Yes. Excess air. So as I was saying, nitrogen oxide reacts with water to form nitric acid and nitrous acid. This is the formula of nitric acid and this is the formula of nitrous acid. The difference is nitric acid has 3 oxygen while nitrous acid has 2 oxygen. Nitrous acid has 2 oxygen. So this equation occurs at the absorption tower, and at the absorption tower, as we have said, water is added, then excess air is also added. So the excess air added oxidizes nitrous acid to nitric 5 acid. The excess air added oxidizes the nitrous acid to nitric 5 acid. So this nitrous acid we are adding in excess air which is oxygen to form nitric 5 acid. So that is the equation. No, it's not balanced. I think here is 2. Here is 2 hydrogen, 2 nitrogen, 2 nitrogen, oxygen. That is 4, 5, 6. Yeah, it's balanced. So now we have formed our nitric 5 acid. So then another thing that we need to take note of, the nitric 5 acid obtained, the nitric 5 acid that is obtained, it is not pure. This nitric 5 acid, it is not pure. This nitric 5 acid, not pure, which means it contains some impurities. So how can we remove these impurities? What we are going to do, we are going to carry out further distillation now to obtain nitric 5 acid that is pure. We are going to carry out further distillation. This is a question that in most cases usually come in paper 2 chemistry. So some of the things that are usually recycled in this Ostwald's process. As you can see this arrow from absorption tower, we are coming back to the compressor, which means we have some of the things that have not reacted and therefore should be recycled. So we have air, unreacted air, then ammonia and nitrogen oxide. Unreacted air, we have ammonia, then and nitrogen oxide. Unreacted air, ammonia and nitrogen oxide, these are the substances that are recycled. They are recycled. Ammonia, unreacted air and nitrogen oxide are recycled in the Ostwald's process. So let's talk about the properties of dilute nitric 5 acid. Let's talk about the properties of dilute nitric 5 acid. Here we are talking about the dilute nitric 5 acid. You should take note, because we are going to I'm about to talk about concentrated. There are just few, there are 3. So reaction with metal carbonates and hydrogen carbonate, metal carbonate and hydrogen carbonate. So when you take a metal carbonate plus dilute nitric 5 acid, you have a metal carbonate, here a metal plus dilute nitric 5 acid. What are we going to form? So we shall form a metal nitrate plus water plus carbon dioxide. That's what we are going to form. A metal carbonate, when you react with dilute nitric 5 acid, we are going to form metal nitrate plus water plus carbon dioxide. So a dilute acid, the state symbol, this is another thing that you need to take note of. The state symbol of a dilute nitric 5 acid and concentrated nitric 5 acid is not the same. It differs. For dilute acid, is it aqueous or liquid? For dilute acid,
Dilute.
yeah, is it aqueous or liquid?
Liquid.
Liquid. Dilute acids do not react with metals, low hydrogen, it reacts with copper to produce. It's aqueous. A dilute acid is aqueous. This is a very key point. It can make you to lose a half a mark or even 1 mark if the examiner is very keen, if he or she considers the state symbols when he is marking your paper. So reaction with metal hydroxide plus dilute nitric 5 acid, metal hydroxide. Here I'm just making a symbol summary. Metal hydroxide plus nitric 5 acid. We are going to form a metal nitrate plus water. Metal nitrate plus water. Metal nitrate plus water. So reaction with metal oxide, we have metal oxide plus nitric 5 acid, metal oxide. If you have a pen and even a book or a paper, you can write these short notes, they can help you. Metal oxide plus nitric 5 acid. What are you going to form? We shall form a metal nitrate plus water. Metal nitrate plus water. Metal nitrate plus water. That's what we are going to form. So NB, dilute nitric 5 acid does not usually give off hydrogen with metals. Dilute nitric 5 acid does not usually give off hydrogen with metal. This because it is a powerful oxidizing agent. Nitric 5 acid, it is a powerful oxidizing agent. So instead of giving off hydrogen gas, the hydrogen that is going to be produced will be oxidized to water, simply because it is a strong oxidizing agent. So let's look at the properties of concentrated. Now let's see if there is a difference or it's just the same. Properties of concentrated. Concentrated nitric 5 acid, first you should take note that it is a powerful oxidizing agent. It undergoes the following reaction. 1, it reacts with green iron 2 sulfate. It reacts with green iron 2 sulfate acidified green iron 2 sulfate, acidify with dilute sulfuric 6 acid to form a yellow brown solution of iron 2 sulfate. A yellow brown solution of iron 2 sulfate. That is the brown ring test. The brown ring test. This is a simple diagram of what I'm talking about. I'm not good at drawing, but you just understand. The brown ring test. A simple diagram showing a brown ring test is carried out. We have a mixture of acidified iron 2 sulfate and concentrated nitric 5 acid. Acidified iron 2 sulfate. Acidified, which means it has hydrogen, it has been acidified, and we have say acidified iron 2 sulfate and concentrated nitric 5 acid. Concentrated nitric 5 acid. A symbol diagram showing how brown ring test is carried out. Those are the red-brown fumes of nitrogen oxide. The red-brown fumes of nitrogen oxide. Nitrogen oxide. The red-brown fumes. These are red-brown fumes of nitrogen oxide. This is just a simple diagram, but it can be asked in paper 1. You should be keen in answering such like a question, because it can be, an examiner can trick you in different ways. He or she will not draw the diagram, but will ask this question in a hidden way. So if you are a serious student, go and look at those questions, sample questions that are asked concerning the relating with the brown ring test of nitric 5 acid. So number 2, it reacts with copper to form copper 2 nitrate, water and nitrogen oxide. Number 3, it reacts with sulfur to form sulfuric 6 acid, water and nitrogen oxide. So now let's look at some of the uses of this nitric 5 acid. Uses of nitric 5 acid. What are the uses of nitric 5 acid? 1, we have the manufacture of fertilizer, e.g. ammonium nitrate, manufacture of dyes, manufacture of fertilizer. We have dyes. Then we have drugs, some drugs, nitric 5 acid is used to manufacture some drugs. Then lastly, we have manufacture of explosives. Manufacture of explosives. Explosives. E.g. TNT. Now you know, nowadays examiners are very fun. You can just get maybe number 10 in chemistry paper 1. Write TNT in full, or what does the word TNT in full mean? So let me give you the answer. TNT in full means trinitrotoluene. 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 1 mark or even a half a mark, it will depend. Trinitrotoluene. That is the meaning of TNT. TNT. Now as I finish, let me talk about some of the questions most asked, the questions that are most asked in this subtopic of nitric 5 acid. So like last year in KCSE paper 1, they were asked to write the complex compound formed when ammonia and copper hydroxide reacts. When ammonia and copper hydroxide reacts, write the complex compound that is going to be formed. That's a question that was asked in last year KCSE paper 1. KCSE paper 1. Now you see, chemistry paper 1 is very fun. You need to be serious or to take serious with your studies so that you can score at least something good. So here we are having two copper hydroxide reacting with ammonia. Copper hydroxide is reacting with the ammonia. Ammonia form tetraamine copper 2 . This is the complex compound form tetraamine copper 2. Here is 3, sorry. Tetraamine copper 2 ion. Here is 4. Here is 2 ions. The 2 ion copper ion, tetraamine copper 2 ion plus 2 OH ions. This was the compound that was required by the examiner. Here is what the examiner was trying to test. If the students knows how to write this complex compound. So this complex compound is just copper, tetraamine copper 2 ion, copper plus ammonia to form tetraamine copper 2 ion plus 2 hydroxide. The same compound will be formed when you replace this copper with zinc. That's another question that is usually asked. Zinc hydroxide plus ammonia to form tetraamine zingate ion, tetraamine zingate ion, something like that. It is, I think it is in form 3, behind form 3 KLB. You can read those ion, complex ion, form 3 KLB, you'll get those ion. Yeah, you can confirm at your free time in KLB, page 241, you'll get the ions that I'm talking about. So this tetraamine copper 2 ion, it is a deep blue solution. It is a deep blue solution. Deep blue solution. It is a deep blue solution. And copper hydroxide, it is a pale blue PPT or precipitate. So Mr. Jacob will explore more about these ions because it usually comes in paper 3 practical. So you'll explain more about it. So another question that was asked in KCSE 2010 paper 1, you may not know, you can also be asked the bond that is existing between these two elements. You have copper and ammonia. So between copper and ammonia, we have a dative covalent bond. Dative covalent bond. This is a KCSE question that was once asked in 2010. So from there, I think Mr. Jacob will explore more about this ion. Thank you for listening.